Welcome to this session of Operations Management series, and welcome to the session on maintenance management once again. In the earlier session of maintenance management, we have talked about the importance of maintenance management in the organizations. We have talked about the objectives of maintenance management. We have talked about the types of maintenance management. So broadly, we talked about four types of maintenance management. The first one is the breakdown maintenance or corrective maintenance. The second type is the scheduled maintenance or routine maintenance. The third type is the preventive maintenance. And the fourth type of maintenance is predictive maintenance. We also talked about that if there is no proper maintenance of the plant and equipment, then it has the impact on the production capacity. You will not be able to utilize the full production capacity of a plant. There will be production costs. The production cost will be more because you may have to spend more on a very costly part or a component of a machine. You will not get the right product and service quality, and it will also hamper the employee safety or even the customer safety. So good maintenance also ensures that you maintain proper safety procedures, and ultimately it will cost you the goodwill in the market, and ultimately your customer may not be satisfied. Now, if you see the maintenance usually maintenance departments are there in organization, and typically there will be a maintenance manager. And maintenance manager in a manufacturing organization is a plant engineer who reports to a plant or manufacturing manager. And maintenance department are usually split into two groups: building and grounds, equipment. So for equipments, plant and machinery, you need a different kinds of maintenance strategy. For civil construction, for buildings, you need a different maintenance strategy, and the technical skills required are also different. And the risks are also different, the stakes are different. So based on that, you decide your maintenance strategy. Now maintenance now has come to that level which is a very advanced level. We talk about something called TPM, called total productive maintenance. Now today we will see the conceptual part of what is total productive maintenance. Although in detail we will be talking about TPM technical details in a separate session. So if we see from the slide what is the definition of TPM or total productive maintenance, it's a partnership between the maintenance and production organization to improve product quality, reduce waste, reduce cost, increase equipment availability, and improve maintenance state. So, for example, there is a concept called total quality management. Similarly, this concept is also just like total quality management. This is total productive maintenance. Like in total quality management, earlier in quality, what used to happen that quality was taken care by the last department in an organization. The manufacturing department used to produce the product, then it used to go to the quality department, and the onus was on the quality department to test that particular product, whether it complies with the required standards or not, and they will put the stamp accepted or not accepted or rejected. TQM concept said that why in the very first place you made that defective product. So quality is not just the responsibility of the quality department alone. Quality is the responsibility of each and every person. So quality was the responsibility of the operator also, the machine operator also. Quality was the responsibility of the person who was in the purchase department also, because it might happen that this product is defective because the raw material which was used to produce that product was defective, and that raw material was purchased from a vendor. So at that point of time, nobody took care that this raw material was defective, and you started manufacturing that raw material. And definitely the final product will be defective. For example, you can draw an analogy from your homes. If you have purchased stale vegetables, and if you cook it, you put other ingredients into it to cook a vegetable, a cooked vegetable. So you have wasted all those ingredients also, and you have wasted the fuel, your gas, your LPG gas, your labor. So in the very first place, you should not have bought that rotten vegetable. So the same concept applies to, so TQM says the same concept applies to TQM also. It says that quality is the responsibility of every person. So to explain to you in a very layman's language. So similarly, total productivity management or total productive maintenance, or sometimes we also call it total preventive maintenance. It is not the duty of the maintenance department alone. It is the duty of the operators also who are operating the machine. It is the duty of the production manager also. So that is the concept of total productive maintenance. So total productive maintenance, you can say it's a maintenance program which involves a newly defined concept for maintaining plants and equipment. The motive of TPM is zero error, zero work related accident, and zero loss. So nothing is left to chance in TPM. There should not be any error in the product. Zero defect products you have to make. Zero accidents, because they will not compromise on the safety. And zero downtime of the machine. Zero breakdowns. So ultimately it will result in zero loss. Now let us see what are the objectives of total productive maintenance. From the slide you will see, number one, maximize equipment effectiveness, develop a system of productive maintenance for the life of the equipment, involve all departments that plan, design, use or maintain equipment in implementing TPM, actively involve all employees, promote TPM through motivational management. So as I explained to you earlier, the ultimate aim is also to maximize the equipment effectiveness also, because equipment should run at its full efficiency. You should avail of the full, you can say, efficiency of the equipment if you are properly maintaining your machines. So ultimately the life of the equipment also get enhanced. And as I said, its maintenance is not the duty of just one department or a few people. It is the duty of everybody. So people who are into planning, into designing, and they all should be contributing to maintenance activities. They should draw a strategy for maintenance. You should actively involve all employees, and motivational trainings should be done, and each and every staff of other departments should also be trained how to maintain the plant and equipment of an organization. Now, there are the so-called 8 pillars concept of TPM. What are those concepts? So, number one, focused improvement for eliminating waste. Autonomous maintenance. Here the operator is the key player. It involves daily maintenance activities carried out by the operators themselves that prevent the deterioration of the equipment. Planned maintenance for achieving zero breakdowns. So, there should be efforts to eliminate various kinds of waste. Waste of overproduction, waste of downtime, waste of defective products. And then there is a concept called autonomous maintenance. Here, instead of the fact that there is a different person who will maintain the machine, who will lubricate the machine, operator is some other person, and there is another person who will lubricate the machines, who will clean the machines, who will do some kind of repairs. So broadly, the operators should be trained to do the maintenance also. So operator is the key player. So that is the concept of TPM. So again, I will draw an analogy to make it very simple for the public at large. For example, you have a professional driver who drives a car. This driver may be very good in driving the car, But a professional driver is also expected to know some repair work of a car. If a driver does not know, let's say, very simple, if the tire gets punctured and the driver does not know how to change the tire, then that driver is of no use. Will you like that driver? So as a professional driver, so even if you are not a professional driver, like a person like myself or you and me, if we drive our own cars, so we should also know how to change our car, how to use the jack and change the tire. If we are driving somewhere on the highway, in the market, in the city, we should be able to do that. However, a professional driver is also supposed to open the engine or see, some small problems, he should be able to correct it. So that concept has been now applied to the industries. That is called autonomous maintenance. Now, what are the various steps of this autonomous maintenance? Number one, clean and inspect. Number two, eliminate problem sources and inaccessible areas. Draw up cleaning and lubricating standards. Conduct general inspections. Conduct autonomous inspections. Standardize through visual workplace management. Implement autonomous equipment management. So these are the 7 steps of autonomous maintenance. Clean and inspect. You are operator, machine operator, and you will say, I will not clean, I can't inspect the machine. So you can't come to that level of preventive maintenance or predictive maintenance or total productive maintenance, because the staff who will inspect the machine is a different staff. Then you can't expect to have this total productive maintenance. So you have to train your operators to even inspect, and you have to put in their KRAs, key result areas, that they have to clean the machines also. Even they should be trained to go to inaccessible areas in a plant. They have to draw in fact the lubricating schedules, cleaning schedules. They should be able to conduct general inspections, autonomous inspections. So that is the concept of autonomous maintenance, which is part of total productive maintenance. Now, what are the other pillars, concepts of TPM? Education and training for increasing productivity, early equipment or product management to reduce waste occurring during the implementation of a new machine or a production of a new product. Quality maintenance, it includes the most effective quality tool of TPM, which aims to achieve zero loss by taking necessary measures to prevent loss. So education and training is a very important part of total productive maintenance. So because new machines will be coming, some new parts will be coming, new technologies are coming, you have to constantly train your people to operate the machines as well as to maintain the machines, to inspect the machines. You have to train them for waste reduction, and you have to ensure that quality is maintained, because quality and TPM go hand in hand. So TPM is a part of total quality management, so which aims to have zero defects. Not only zero defects is a part of quality, but zero downtime of the machines, zero accidents is the aim of total productive maintenance. What are the other pillars, concept of TPM? Other pillars are safety, hygiene, environment. For achieving zero work-related accidents and for protecting the environment. Then there is a concept of office TPM for involvement of all parties to TPM, since office processes can be improved in a similar manner as well. So when we talk about total productive maintenance, you have to take care of safety, you have to take care of hygiene also, because you cannot expect to have good maintenance procedures if the hygienic environment is not there, proper environmental conditions are not there, proper ventilation conditions are not there. proper ergonomic conditions are not there, so that the workers can work in a good environment, in hygienic environment, in stress-free environment. The workstation should be manufactured ergonomically, the height of the workstations, etc. So all that has to be worked on. Proper foundations of the machines, proper covering for the machine, for the electrical accessories, circuits, for belts there should be proper guards, because you have to protect not only the internal environment, you have to protect the external environment also. So those parts are also you can say parameters for TPM. Now, when we come to breakdown maintenance, now let us once again visit the various kinds of maintenance, because in some cases, as we told in the last session, that in certain equipments probably breakdown maintenance is also the right strategy, because some equipments do not require regular maintenance. So when you comply to breakdown maintenance, what are the objectives? Number one, the objective is to get equipment back into operation as quickly as possible. Control cost of repair screws, control cost of operation of repair shops, control the investment in replacement spare parts, control the investment in standby or backup machines, perform the appropriate amount of repairs at each malfunction. Now, suppose the company is resorting to this strategy of breakdown maintenance. So what should be their strategies? Their strategies should be that spare parts should be available, standby machine should be available, so that in case the equipment has got breakdown, you immediately have spare parts, or you immediately have standby equipments, so that the production do not get hampered. Then secondly, the repair should not be very costly, and appropriate amount of repairs should be there at each malfunction. So therefore, ultimately the aim is to minimize the interruptions to the production, and the working condition should also be safe, and your product and service quality should also improve. So that is the aim. However, if you are adopting a maintenance strategy, that is breakdown maintenance strategy, then you may have to employ some specialists. They may have to work overtime, and there should be supervisor or engineers should be there nearby to collaborate. Standby machines may be quickly put in operation. So all those mechanisms should be put in place. Now let us see this graph, how speedy should repairs be. Now the x-axis shows the speed of making repairs, and the y-axis shows the cost. The red curve shows you the cost of repair, the blue curve shows you the cost of interruption to production, and then you get the total cost. So again, when you draw a perpendicular dotted line, you see that the minimum cost comes when the two costs, that is cost of interruption to production and the cost of repairs, are equal. So somewhere you also have to see how speedy the repair should be done. For certain equipments which are not critical, you can delay some repairs. You should not spend so much time to get speed repairs, because when you want to go for speed repairs, it will be costly affair. The spare parts in emergency will be available at a high price. So therefore, an equipment breakdown will trigger two action: fast repair of the malfunction equipment, or medium speed of malfunction equipment, or slow speed of repair of malfunction equipment. So you have to trade off in between. So therefore, what should be the extent of repairs possibilities? We say that you do just enough repairs to get equipment running again. You have to repair the malfunction and replace some parts that are worn out, perform a major overhaul of the equipment, replace the old equipment with new. So these are the various possibilities. In your day-to-day life also, in your homes also, somewhere you have to decide. Suppose your refrigerator has some problems. So should you get the refrigerator repaired? Should you go for the overhaul of your refrigerator? Sometimes there comes a time when you find that you have spent so much of money in repair of that refrigerator, it is now no longer economical to repair this old refrigerator. So it's now time to replace it with the new refrigerator. So do not spend time. So therefore, in an organization, in a large industry also, you have to decide all these possibilities, that what level of repairs. Sometimes you say, you just repair in your homes also. Suppose you have called a service engineer or a service mechanic to your homes. He says that if you I'll just repair the refrigerator. You need not change the full part. I'll just do some repairs so that it will just start running again. Sometimes you say, no, I want the full assembly to be changed. Or sometimes you say, no, I will change the whole refrigerator itself. There is no point on repairing it. So the same analogy you can apply for any major equipment or for any plant and machinery. Then in the organizations also, you have to decide what should be the size of your human personnel. So for example, you can say there are various models. Queuing analysis is there, computer simulation is used, that you have to decide, what kind of size of repair crews you should have. Then you have to also decide how many number of standby machines you should have. So you should have a trade-off between cost of lost production time and the cost of machine storage, handling cost, etc. Now, once again we will talk about the autonomous maintenance part, wherein we are saying that the operator should be trained to maintain their own machines. So let us see what are the further advantages of letting workers repair their own machines from this slide. So here we are saying greater variety may make job more satisfying for such workers, may be more sensitive to potential malfunctions, increase flexibility, can make minor repairs faster, can avoid minor repairs by cleaning, lubricating, adjusting and servicing machines, operate machines more carefully. Suppose in your homes also, if you know some small if you possess some small technical skills, probably you can do some corrective action to your equipments. It may be an air conditioner, it may be a refrigerator, it may be a TV set, it may be a mobile phone. Yeah, in case of major repairs, then you take it to the service center or you call the service mechanic over there. So similarly, the concept of autonomous workers is that the workers should be trained, the operator should be trained, the supervisor should be trained to do the minor repairs themselves. So that is the concept of total productive maintenance. So ultimately, in productive maintenance or in preventive maintenance, the aim is to reduce the frequency of interruptions, also to reduce the severity of interruptions due to malfunctions, to extend the useful life of equipment, to reduce the total cost of maintenance by substituting preventive maintenance cost for repair cost, to provide a safe working environment, to improve product quality by keeping equipment in proper adjustment. So those are the ultimate aims, to increase the overall effectiveness of your equipment. So how do we define overall equipment effectiveness? This is another concept called OEE. Overall equipment effectiveness nowadays is a key metric to measure the performance of individual equipment. Now there is a formula for that. For example, we are saying one company producing deep drawn steel components using a power press which is having equipment availability of 50% and performance rate of 70% and quality rejection rate of 20%. So overall equipment effectiveness, there is a formula called A into P into Q. A is the equipment availability, P is the performance rate, Q is the quality rejection rate. So if it is in the example it is given, so you multiply 50%, that is 0.5, 70%, that is 0.7, quality rejection rate 20%, that is, so that means the right materials are just 80%, so 0.8, that is 28%. So you have been able to get only 28% overall equipment effectiveness. So therefore, preventive maintenance has got coordination with the operation strategies. Nowadays, what is happening, a lot of automation is also happening. So you find that there are less workers in the factories. We are seeing that there is a shift from large to smaller production workforce. So then there is a challenge to the maintenance activities, especially the preventive maintenance activities. So then there are database requirements are also there. You need detailed records, ongoing history should be maintained on each machines, dates and frequency of breakdowns, description of malfunctions, cost of repairs, machine specification checklist for preventive maintenance inspection. Computer generally used to maintain a database. So a complete record, maintenance records have to be maintained. So complete database management is also part of maintenance management, wherein you should have details of each machines, that on which date this machine had got breakdown, what was the frequency of the breakdown of this machine. So mean time between breakdowns. So this is another term which is used, mean time between breakdowns. If the mean time between breakdowns is coming to be very small, so that means there is some problem with your maintenance management, because the machines is getting breakdown very frequently. Then there is another concept of mean time between repairs. So again, if it is very small, then it is a cause for a red flag. That means you are getting your machines repaired very frequently. So these concepts also, so these figures you can draw from the database. What was the nature of the malfunction? What was the overall cost which was required to repair that? So you can draw conclusion from that what kind of strategy, maintenance strategy you must adopt for this. So now there is concept of decision analysis and preventive maintenance. You have to determine how many number of spare parts you should carry, how many number of standby machines you should have. So there are nowadays formulas also, so we will just see this formula on the screen, that expected number of breakdowns. Now here also you have to predict is equal to n into sigma Pn into 1 plus. So all this formula is, what does it say? So where Bn is equal to the expected number of breakdowns for each of the preventive maintenance policies, Pn is the probability that a breakdown will occur between preventive maintenance inspections when preventive maintenance is performed every n periods, and capital N is the number of machines in the group. So for the one machine you are calculating the probability of the breakdown, for the second machine you are calculating the probability of the breakdown for the third machine, and so on. So through this you can also draw a probability of the expected number of breakdowns on the machine, and based on that you can draw the strategy of your maintenance plan. So in large scale, then there are large scale projects. In that again preventive maintenance has a challenge. and you can use project management techniques over there, critical part methods technique over there, PERT, project evaluation and review techniques can be used for maintenance. So you have to have different approaches also to improve the machine reliability. You can change the design of your machines, of your product, of your layouts, and then design should be simple. Nowadays the concept is of design simplification. You should also see that there are no redundant components, etc. So I hope that you have got a fairly overview of the maintenance management in the organization. So ultimately I would say the last few words, that you have to empower your workers so that they may own their own machines. You can also implement just-in-time systems in your manufacturing systems. You have to invest in your factory and service automation projects. Then you have to utilize the automated process sensing and control systems, and you can use computer database in maintenance management. So we will suggest you to read some good books on this topic, and we will be talking about total productive maintenance in more detail in the coming session. So thank you so much.